So hello everyone, I am Sivasankar Hasta. Welcome back to my YouTube channel, your KGPN Raw. In this video, I am going to discuss about oxidation and reduction and how to find out the oxidation state of a particular atom. So let's start. So first of all, let's see what is an oxidation and a reduction. So here is the two concept. This is the all concept, and according to the all concept, oxidation means either addition of oxygen or addition of an electronegative atom or removal of hydrogen, or you can say removal of an electropositive atom. So here is an example. The given reaction is magnesium plus oxygen is magnesium oxide. Here the magnesium is receiving the oxygen, so magnesium is undergoing oxidation. Similarly, here sodium plus chlorine gives rise to sodium chloride. The atom sodium gains chlorine, which is an electronegative atom, so sodium atom is undergoing oxidation. So similarly, the reduction means either of the following process: removal of oxygen, or you can say removal of an electronegative atom, or addition of hydrogen, or addition of an electropositive atom. Any of the process means reduction. So here is an example: sulfur is being added with hydrogen to give rise H2S. So here sulfur atom is undergoing reduction. So this was the old concept, but according to the new concept, oxidation means either removal of electron, or you can say in other word, it is the increase in oxidation number. So here is Mn3 plus, it gives rise to Mn plus 5 and it gives 2 electron. That means Mn3 plus is losing 2 electron, and the loss of electron is nothing but the oxidation. Similarly, here it is going from SnCl2 to SnCl4. Here the oxidation number of Sn is plus 2, and here the oxidation number is Sn of oxidation number of Sn is plus 4. So here there is the increase in the oxidation number, so SnCl2 is undergoing oxidation. The reduction means addition or gain of electron. So here Fe3 plus is gaining 1 electron to convert Fe2 plus. So here Fe3 plus is undergoing reduction. Similarly, we can say that reduction is nothing but decrease in oxidation state. So these are the brief overview of oxidation and reduction. So let's see about the oxidation number. So what exactly is a oxidation number? So it is nothing but an imaginary or apparent charge gained by an element when it goes from its elemental free state to combined state during the formation of molecule or compound due to its electronegativity difference. So it is nothing but an imaginary or apparent charge which is developed by an element when it goes from its elemental free state to combined state during its formation of compound. And this oxidation number is nothing but because of the electronegative difference. So there is one question that why it is used, or what is the need of oxidation number, or why we should study oxidation number. The concept of oxidation number is introduced in order to keep track of electron transfer or shift in a chemical reaction during the formation of compound. Uh, Concept of oxidation number is introduced in order to keep the track of electron transfer, or electron shift in a given chemical reaction during the formation of compound. So what basically it signifies? What does it signify? Now, it signifies whether an element gain or lost electron with respect to its free state during the formation of a compound. It basically says whether an element gains or lost electron during a during the formation of compound. So positive oxidation state means loss of electron and negative oxidation state means gain of electron. So if there is a something A3 plus, that means A atoms has lost 3 electron, and A3 minus means uh, the atom A has gained 3 electron with respect to its free elemental state. So there is some certain rule to determine the oxidation number, and this determination of oxidation number is completely based on the electronegativity. So here is some rule. Let's see them one by one. So oxidation number of an element in elemental free state or in allotropic form is 0. Either elemental free state or in allotropic form is 0. Oxidation number of sodium, copper, fluorine, chlorine, any atom in its free state is 0. Similarly, in case of allotropic form also it is 0. For example, sulfur rhombic 0, sulfur monoclinic it will 0, chlorine diamond 0, and chlorine graphite it is also 0. So point number 2, oxidation number of atoms present in homoatomic molecule is 0. For example, H2, O2, N2, P4, S8, these are all homoatomic molecule, and the oxidation number of atom in homoatomic molecule is 0 because there is no electronegative difference. So as electronegative difference is 0, so there is no electron transfer, so there will be no charge. Point number 3, oxidation state of all components of an alloy is 0. So here is an example of alloy, sodium amalgam. So as in alloy there is no transfer of electrons, so there will be no charge. So oxidation number of all the components which are present in an alloy are 0. So for example, sodium amalgam, here the oxidation number of both sodium and both Hg is 0 because there is no electron transfer. Point number 4, the algebraic sum of oxidation state of all atoms present in a polyatomic neutral molecule is 0. The algebraic sum of all the oxidation state of all the atoms present in a polyatomic neutral molecule is 0. Here is the point number 5. The algebraic sum of oxidation state of all the atoms present in a polyatomic ion is equal to the charge on ion. So these 2 points are very important. So these 2 points are to be kept in your mind. So here is the oxidation number table. So this is very important. So these are the some atoms whose oxidation number is always fixed. So fluorine, which has oxidation number -1, and that is always. Alkali metals, that means sodium, potassium, rubidium, cesium, etc., they have the +1 oxidation number in all of their compound. Similarly, for alkaline earth metal like barium, magnesium, calcium, strontium, barium, their oxidation state is always +2 in all of their compounds. These are always. Similarly, for aluminum it is +3 and it is also always. For Hg, that means silver, it is the +1 and it is always. So for this type of elements there is no exception, so they are always holds. So first of all, check whether these type of elements are present or not in a given compound. So if present, then always allot them their corresponding oxidation number without any exception. So this is your first task, that you have to check whether in a given compound these elements are present or not. If they are present, then immediately allot them their corresponding oxidation number without any exception. So then it comes hydrogen. Hydrogen is basically +1, but in metal hydride its oxidation state is -1. For example, you can say that in sodium hydride, sodium is +1 and hydrogen is -1. Oxidation number of oxygen is -2 in general, as well as in peroxide, but in in oxide it is -1, -2, but in peroxide it is -1. In superoxide like KO2 it is -1/2. In ozonide like NaO3 it is -1/3. OF2 it is +2 and O2F2 it is +1. So this is the priority order that you have to remember. So first of all, you check these elements in a priority wise. first of all you have to check whether fluorine is present or not. If you say fluorine, then immediately assign it to oxidation number -1. Then search for alkali metal. If found, then always give them +1. Then find alkaline earth metal. If they are found, then immediately assign them +2 oxidation number. Then aluminum, then Ag, then hydrogen, oxygen, in this order. So this is the priority order. Whichever element comes first, assign its oxidation number first. You have to assign their oxidation number first. There is some exception, or you can say that there is a basic method to determine the oxidation number. From the exact oxidation number, or if you want the individual oxidation number, then you have to know the structure of that compound. So here is a beautiful example, which is nothing but CrO5, that is known as ferrochrome, which is blue in color, which structure is given like this, and this is known as the butterfly structure. So if you calculate the oxidation number of chromium by X method, then it will be +10, which is not impossible, which is not possible. So you have to determine the oxidation state of chromium by the help of structure. Here is structure. So in case of structure, what you have to do, you have to go on breaking all the bonds. While breaking single bond, you have to give +1 to the less electronegative atom and -1 to the more electronegative atom. Similarly, while breaking the double bond, you have to give +2 to less electronegative atom, -2 to more electronegative atom. Similarly, while breaking triple bond, you have to give +3 to less electronegative atom and -3 to more electronegative atom. So this is the oxidation number through bonding. While breaking covalent bond, if it is a homoatomic molecule, then if the bond is between similar type of atom, then you have to give 0 to both, whether it may be single bond, double bond, or triple bond. If the bond is between two similar type of atom, then always assign 0. If the electronegativity of A is greater than electronegativity of B, then for single bond you have to assign this to -1 and this to +1. Similarly, for double bond case, you have to assign -2 to more electronegative atom and +2 to less electronegativity. For triple bonded cases, you have to assign -3 to more electronegative atom, +3 to less electronegative atom. For coordinated bond, going from more electronegative atom to less electronegativity atom, you have to assign +2 and you have to assign this to minus. Here it should be like electron to B, electron to A to A, you have to assign +2 and -2. So if a electronegative atom, if a coordinated bond is from higher electronegative atom to lower electronegative atom, then you have to assign 0. So here is the structure. So let's break the bonds one by one. While breaking this bond, we have to give oxygen is more electronegative than chromium, so you have to assign -1 and -1 to oxygen and +1 to chromium. Similarly, breaking while this bond, this is a bond between two similar atoms, so you have to assign 0 to both of them. Similarly, breaking this bond, you have to assign -1 to oxygen as it is more electronegative than chromium. While breaking this bond, you have to assign +2 to this chromium and -2 to oxygen, as chromium is lesser electronegative than oxygen. So we have to break all the bonds, and then finally you have to count the total charges on chromium, which is nothing but +5. So here is some example. We have to determine them by X method, and the another is structural method. So here is an example, which is Na2O2. So first of all, you have to use the priority order. As it is alkali metal, it is always +1. So by applying 2 into +1 plus 2x is equal to 0. So from x is equal to -1. Similarly, these other examples can also be determined. There is no issue. Here is an example of H2S2O8, which is nothing but Marshall's acid, or you can say par disulfuric acid. If we calculate the oxidation number of sulfur by X method, then it comes out to +7. and it is not possible because we know that for p block element oxidation number vary from n to n minus 8, where n is the valence electron. So you have to determine their oxidation number from the structure. Thank you for watching.